Good afternoon. I'm here at Soilless Farm Lab. Walk us through the hydroponic system we're seeing here.
All right, good afternoon. Here we do hydroponics farming, or the one they normally call soilless farming, soilless agriculture. And there are two types here. We have the one that we use substrate to grow crops. Substrate from rice shafts, the one we call rice hull. Then we have the cocoa pits. We use them to grow crops instead of soil. Then we have the other one that we use basically water. And the system we're running here is the deep water culture. In the deep water culture, it serves even dual purposes. It can serve as the hydroponics proper, and it also serves as aquaponics, because at times we use the water from the fish to feed the plants in the deep water culture. So it's like a circular economy here. Even the poultry waste feeds the orchard. Then for the one that we use substrate in grow bags, we have a technology that uses drip irrigation. Drip irrigation helps to conserve water by 50%. So in that case, we do not need to worry about water, and we do not waste water. So it is drip irrigation. That is our flat drip tape that we use to feed the plant. And I must say that it is very, very effective.
Welcome back to Africa Science Focus, the science and development show from SciDevNet. I am Ogechi Kenyao. That was Modupe Olafusi, greenhouse manager at Soilless Farm Lab in Abuja, Nigeria. Modupe uses hydroponics and soilless agriculture to help address food scarcity. She tells us this method can address hunger in Sub-Saharan Africa, where it remains a significant challenge. According to the Food and Agriculture Organization's 2023 report, hunger in Sub-Saharan Africa increased from 22.2% to 22.5% in 2022. While this may seem like an insignificant increase, it does mean that more people in the region are being thrown into increasingly acute hunger. Many factors contribute to hunger and food insecurity, including climate change and conflict, and they make traditional farming methods increasingly challenging. As a result, innovative approaches are needed to address food insecurity in the region. One such approach is hydroponic farming, also known as soilless or climate-smart farming. This method offers an alternative solution to traditional agriculture, particularly in areas prone to conflict and with limited arable land. By using nutrient-rich solutions rather than soil, hydroponic farming can increase crop yields and provide food security in regions where it's needed the most. Our reporter, Abdulkareem Mojeed, speaks to Professor Adeniyi Olayanju, who explains what hydroponic farming is and how it differs from traditional agriculture. He highlights its benefits and potential to address food insecurity.
What we meant by hydroponic farming or hydroponic technology, or what is called soilless farming. If you look at the word hydroponic, hydro means water. Ponic means work. So hydroponic means putting water to work. And so when you are talking of hydroponic, we are saying it is not necessary or compulsory that we make use of soil. That's why it is called soilless. Prior to now, we used to think without soil we can't grow crops or we can't do farming. But hydroponic has made us to know that farming can be done even outside of using soil. There are different hydroponic methods, and it depends on the kind of crop that we want to grow. But let me quickly run through it. There's what they call the NFT, which is the most popular one. It is called the nutrient film technique. And this one is used to grow crops that are not heavy eater. They are light eater. Then you also have another one that is called floating bed technique. That one you immerse in a pool of water. that one is meant for every water consumption crop. But you now have other one that you grow in the greenhouse or the screen house under a controlled environment. You can have the one that they call the trough technique. You just have a rectangular trough. It depends on the length you want to go. It can be as long as 24 feet. And then you now bring substrate. The first two, they don't use substrate. It's direct with the nutrient. It's direct consumption. But in this other one, the trough method, the bucket method, all of this one, they are now using what is called substrate, like the cocoa pit, the rice husk, or the mixture of the two. You can also grow horizontally, you can also grow it vertically. Because in some other area, you may not have enough space, especially in the urban area. Then there's another one that addresses the clashes between the elders people and the farmer, the crop growers. That one is called the fodder cropping system. In that one, you can make use of your arrangement in such a way that your grass can grow in 9 days. And between that, you can start another one the following day that will grow in another 9 days, another one in another 9 days. So you have continuous supply. Because all these animals, they wander around because there are no food for them. There are no grasses for them to eat. But once you are able to do that, then the animal, those elders, they don't have to move around. So those are, in fact, we have about 10 different methods of hydroponics that addresses one crop area or the other.
Modupe shares how she operates hydroponic farming using innovative methods like fish water as manure to grow crops. She discusses how this approach helps mitigate the effects of climate change and herders' invasion with Abdulkareem.
Basically, we know that soil is not what the plant eats. It's the water and the nutrient that is available in the soil that the plant makes use of. The soil is just serving as a support system to the plant. So now, what we use as a support system for the soilless media is rice hull and cocoa pit. We have other substrates you can use. Okay. We have the inorganic, we have the vermiculite, we have the perlite, we have the clay pebbles, we have a whole lot of them. But because we are trying to bring it to something that is affordable and accessible, so we use rice hull. Rice hull is like all over cocoa pits. So that is what we use. We put them in grow troughs. Then the rice hull and the cocoa pits serve as a support system to the plant and also to hold the nutrient for the plant.
Wow, that's interesting and amazing. I was just looking at your orchard setup, and it looks like a place that you can just come and relax in the evening when cashew is ready.
Just harvest.
You pick one and see. No, very nice. I think the place looks beautiful, and the arrangement, I don't think it's quite unique if you ask me. Particularly looking at how you marry orchard, another crop production, likewise the issue of the poultry, where you generate eggs, meat, and it's sort of way whereby I don't think there's anything that goes to waste here.
Not really.
Yeah, I don't think there's anything that goes to waste.
The poultry waste, we attend to the orchard. The fish water feed the plants also.
Wow. So looking at the fish water, what is there in the fish water that provide the nutrient for, they're like farmers in a traditional open, farm system that most of our farmers practice here? I know they go to get NPK fertilizer but here I observe that you're using the fish water. Is that fish water serving as a manure for the plant?
Yes, it's serving as a manure, just like the poultry waste is serving as manure for the plant.
Okay.
The fish water now, it is not like it's already dissolved. The waste of the fish is already dissolved in the water. And for the hydroponics, we need water to feed. So all the waste is in the water that will be made available to the plant roots to absorb and grow. Okay, so our farming system also does not depend on weather. Now, recently we see the issue with vegetables, especially tomato and pepper. What caused that was heat wave that happened. Basically, we know that our farmers are smallholder farmers and they depend on the climate. But when the heat wave came, they planted and the seeds did not even sprout. Some of them that sprouted, the heat caused them to burn. And we had shortage of tomato and pepper, making things very expensive. But with our own farming system, there is nothing like that. Everything is regulated. Even in the greenhouse, we have a fan that even circulates the temperature and everything. The water we use, we give them water at the time they need it. So that is the precision farming aspect of it. And we do not lose our produce. So also, because we use greenhouse technology, our produce are not exposed to pests and diseases. In that case, we do not need to contaminate the environment using chemical pesticides. So we are also, our farming system is, adapting to the climate. We are growing crops in a healthy environment. Our food production is such that is healthy for the farmer, healthy for the consumer, and healthy for the environment.
So, but in terms of this issue of food, farmer header clashes and all of that, how do you see this system as a solution towards reducing the clashes between farmers and herders in the country?
Okay, so basically, when we talk about farming, our mindset naturally goes to the villages because that is the traditional method. But our farming system is such that can be adapted to the urban settings. So now, basically, we cannot say that there is optimum security all over the country. But we have some places that are safer than other places. And our own farming system fits into the safer place. In the city, we can grow vegetables. And when we grow vegetables in the city, we are closer to the very busy people that need to eat them.
To find out the potential of hydroponic farming, Abdulkareem speaks to Ernest Larmie, co-founder and chief executive officer of Farm Estates Limited in Ghana, who tells us about his experience with hydroponic farming and its impact on consumers.
We are focusing on leafy green and fruity vegetables. And when I say fruity vegetables, what I meant is cultivating tomatoes, cultivating bell pepper, and other fruity vegetables that are very essential to our country. And also, when it comes to leafy green, we are also doing leafy greens like lettuce, like herbs, microgreens, and other things as well. In terms of hydroponics, especially vertical, as you can see behind me, the yield is awesome. When it comes to the normal traditional farming, we call them to be growers, right? They grow on a plain field. And if you want to grow, let's say, an acre of lettuce, you have to equally get an acre of land in order to be able to grow that. But when it comes to indoor vertical hydroponics farming, we utilize space very well. Because we are growing vertically, we are able to grow more yield compared to standard greenhouse or normal farming space. And as you can see behind me, this space is not that it's not big space. It's just 12 by 24 feet. And we are able to grow 1,620 heads of lettuce here in just a very small space. So, and space-wise, indoor vertical hydroponics farming gives more yield than a greenhouse or even outdoor farming as well.
Wow. I just want to ask, is there the kind of feedback you get, a perception of people that, get your product, comparing it?
So far, we've had a lot of feedback from consumers. They are particularly happy about they now consuming vegetables. Vegetables, you don't cook them, right? Especially lettuce, you eat them raw. And for it to have poison in there for you to one, not being able to know where the food is coming from, being traceability. With our way of farming, they are able to trace where the food is coming from, and they are rest assured that the vegetables that are coming on their table do not contain only harmful chemicals that will harm them or harm their children. So they are particularly happy about it, especially immediately they order straight from the farm, it gets to their table. So the produce are really fresh and also really nutritious. In terms of the lifespan of our produce, when it comes to the normal conventional farming, because they apply a lot of pesticides and they are not controlling most factors, their produce get to perish very quickly. But with ours, it can last, I think for the experiment that has been conducted, it can last 3 weeks before it starts going bad. So when it comes to shelf life, our produce have more days spending on shelf than conventional produce that you see out there.
Wow.
So our customers are really happy about that.
Professor Adeniyi and Ernest highlights the benefit of hydroponic farming, including its potential to improve food security in the region.
The first of such is that we have spoken about the use of water use. In hydroponic method, there's what you call precision farming. In fact, hydroponic method is a part of precision farming. In that case, if you need so amount of water, that is what you apply to the crop. That's what you call crop water requirement. Like they will say, woman may drink 1 cup of water when you wake up daily. So for crop also, there is a water requirement that is needed for them. And then once you have been able to calculate that water requirement from literatures, from experience over time, each crop have their water requirement. And then you mix nutrient with them and then they'll be able to utilize. Instead of, unlike the traditional method, for example, you do surface irrigation, you just pour water anyhow. Some of them will percolate or sink into the soil. Some of them will be drained away, even without having contact with your crop. But in hydroponic, there is water use efficiency. So that is the first thing. The second one is in the area of yield. When you talk of growing crop in hydroponic farming and then comparing it with that of traditional, you will find out that they have they make use of land, they utilize them, and then there is no wastages. In fact, that is what hydroponic is even meant for. It's meant for places like urban area where there is no enough land space to grow crop. Then the other one is you look at the yield also, in terms of the yield that they bring and all of that. And then even the quality, because most of the hydroponic crop, they are grown in greenhouses or at least screen house to screen out all these insects, things that can reduce the quality of your crop. So those are the major benefits in terms of efficiency of utilization of your water, increase in the yield of the crop, the efficient also or effective utilization of the land, and also the quality production of our crop.
It's a solution. It's a very good solution that when it's adopted, I think it's also going to help every country and help its environment as well. But the thing is, with the initial cost to set up a structure like this is very expensive. And I believe indoor vertical farming is also bringing an opportunity to add up to what we have already in order for us to be able to meet the market demand, right? So if you are doing on a large scale, then in the unit of economics, it makes sense. But with a very little scale, you get to spend more money than what you earn. So I think it's a good thing which one is adopted. It can help food security in every country. And then it can also help everybody to also get a nutritious and chemical-free food to also consume.
Looking at your setup now, is there any way you will say, in terms of climate change, is there any way this setup is also helping to probably reduce the impact of climate change or helping you to boycott the influence of this weather fluctuation on the vegetables you're growing?
Yes. So to answer your question, yes. We've set up this to also look at meeting certain SDG goals that the entire world is trying to meet, and also to help climate change. This type of setup, we are able to mimic any weather condition here. So we are not affected by outside conditions. And then also, because we are growing more in a very small space, we are able to also meet certain, let's say, demand in the market as well. And with indoor vertical hydroponics farming, we get to save 95% water when we apply 100% water in our farm. We get to save 95% because we are using an NFT system. So the water goes and then it circulates and then comes back. Unlike the outdoor farming that they rely on rain, or let's say they have to buy water, they water their plants and then the water just vanishes. With this one, we are able to save water because water is very precious. And then also, we are able to grow all year round because we are indoors. So all factors that are conditions being met, that allows us to grow all year round and not do any seasonal farming. And when it comes to indoor farming, we are not doing any pollution. Being it carbon, because we are doing urban farming, we are closer to our consumers. So the food traveling from the farm to the consumers is very short. And also nutritious-wise, we harvest immediately from the farm. It gets to the plates of our consumers. So the plant also maintains its nutrients. It doesn't travel at a long distance. And we don't also use any chemicals in our farm, especially pesticides. Using pesticides and on outside production, it also affects the ecological environments of every country. Every insect in every country have its own purpose why God have created it. And it have things that it's doing in every forest or in every garden, right? But indoor farming allows us to shield all these pests not to come in our farm. So we don't use any pesticides, which we don't also pollute the environment. And as I said earlier, we don't waste anything. Even the waste that we generated from the farm is also fed to snails to also consume so that they can also grow to be sold in the market. So indoor vertical hydroponics farming have a whole lot of benefits when it comes to climate change. It's really beneficial thing.
But hydroponic farming is not without its challenges, something Modupe talks to us about.
Okay, so the first challenge is the technical knowledge. If you do not have the knowledge, you will have problems doing this, because this one is totally different from the conventional one that we know. So that's the first challenge. Then the second challenge that I will not really count it as a challenge is actually the startup. Every business requires a startup, so in agriculture. So, but it's not really a challenge, although it's a challenge, because when you want to set up, you actually need the capital to set up. For example, if you want to build greenhouses, it will require a capital to set up. Meanwhile, in the long run, it's actually cheap to operate.
Ernest also shared the difficulties he faces in implementing hydroponic farming, including scaling up and overcoming barriers to expansion.
Because we are doing indoor farming, you need to meet certain requirements. The plants need certain conditions to be met appropriately in order for it to work. And because we are indoor, the sun is not coming in. So you have to make sure that the plants are able to do their photosynthesis. And the question is, why did we move indoor? We move indoor because we said we want to make sure we bring better produce to our consumers. And to bring better produce, we have to make sure the food is not poisoned. So pesticides, we know, is poison, which kill pests, and also is harmful to human beings. So in order to make sure we don't use pesticides, we move indoor. And the indoor also have its own challenges. You have to control humidity, you have to control temperature, you need to also control nutrients and many other factors that it's very necessary for the plant survival. We had some challenges in those areas, but as I said, it's been 3 years on NPP, and we've been able to mitigate and then solve all these challenges. And now we are enjoying.
Hydroponic farming offers a promising solution to food insecurity in Sub-Saharan Africa. However, it requires scaling up and addressing challenges to reach its full potential. Professor Olayanju spoke to us about what can be done to address these challenges.
And when you talk of scalability of the farming, having mentioned the factor, the kind of crop that we grow, most of the time, somebody said you start small to grow big. So the issue of initial investment costs, anything you want to do in life, you say, who is it that want to start or build a house or do anything that will not sit down and think about the cost? So the initial investment cost is always the one that chases people away. For example, I've mentioned the issue of greenhouse or screenhouse, because if you want to practice well, you must have those things. So there must be an initial cost. It's a major factor that can affect you scaling whatever you are doing up. And then in the issue of energy cost also, because you are going to be using pump, you are going to be using lighting material, and then you are going to be controlling the climate environment. That's the essence of having the greenhouse or the screenhouse. Then in some area, there may not be direct access to water and nutrients. Even the labor costs that people will need, and then the crop you are growing, are they market driven? How do I identify all of these things? Those are the factors that can affect the scalability of hydroponic farming.
What are those policies that you think can support, the adoption of hydroponic farming in Nigeria and across Sub-Saharan Africa?
Major one, you must have access to credit and then financing. Because for you to go into it, you must have somewhere, you must have your credit. Then, if you can, there is also the aspect of subsidy. Not only in petroleum, you don't need a subsidy. Even in this kind of thing, they can subsidize for initial investment. Then you need to have training. Like I said, we got BIC to train us in extension program and all of that. And also tax incentive. You must reduce tax if you want people to go into it. Because if you are starting something new, it has not been accepted widely. So you must remove the issue of a tax, or you reduce it to the nearest minimum. And then there should also be support for market development and accessibility.
And that's all from us from Africa Science Focus today. If you want to find out more, head to the SciDevNet website, and that's www.scidev.net. Today's show was produced by Alice Hurst, with editing by Ogechi Ekeanyawo and Titilope Fadare, and reporting by Abdulkareem Mojeed. I'm Ogechi Ekeanyawo. Until next time, goodbye. Africa Science Focus is produced by SciDevNet and distributed in association with your local radio station.